Alright, getting started in C, C++, the requirements, Visual Studio installer. Okay, so you can follow this GitHub guide to get your environment set up. It still uses Visual Studio, unless I glazed over it, but that's a pain in the ass, and you get sidetracked into doing some Linux shell thing with MySys, a package manager that emulates Linux style commands, and you end up getting GCC. You don't really need to do all that. Alright, so once you get Visual Studio installed from the Microsoft site, or I don't know exactly where I got it, but you get it somewhere. Yeah, and you just need to get this component C++ Clang. You don't need anything else, but you're always welcome to, I don't know, skim through and read whatever else components may interest you. Once the Clang component is downloaded, you can close Visual Studio Installer. That's all we needed it for. So the next step is we gotta get Clang into our, so Visual Studio Installer put Clang into this file path on your C drive or wherever else your Visual Studio was installed in. It's usually in the C drive. There'll be 3 folders. Well, basically, there should be 3 folders, but there's like 5. One's the x64, one's the bin, and one's ARM64. The x64 is like 64 byte. The regular bin file is 32, and that's like an ARM64 architecture. I'm just gonna put in the 64-bit, but if you ever need to compile to different architectures, well, you're gonna have to change your variables to to the correct one. So setting up system variables, you're gonna have to go search for it in the magnifying glass and search environment variables. Those are global variables on your operating system. Without them, you can't access the path of LLVM through a command prompt. In the system properties, click environment variables. Second pop-up menu, double-click path. And now in the third pop-up is a list of all the environment variables on your computer. Just click new and copy and paste the path from the x64 bin file. Alrighty. And you have Clang installed and working on your computer. That's all you need. You could close the video now. The rest of this video is going to be kind of rambly because a lot of C or C++ stuff, they kind of gravitate more towards Linux or Mac, and they're using GCC or they're using Objective-C or whatever. There isn't really much for Windows, and if there is for Windows, it's using Visual Studio or a crazy IDE. You don't really need all that, or even an LSP. You could just write the code. So why didn't we do MySys option and get GCC and just call it done? Get the package manager, and then we could just download whatever hell we want for C headers. Well, you would understand the pain of trying to use GCC on Windows, and that's because when you do all that, you set up this little encapsulated Linux folder that doesn't actually contain any of the Microsoft C headers. So if you wanted to compile a C project using the standard C library stuff, so if you just wanted to print something onto the command prompt when you run your executable, you're gonna have to find and link all the headers yourself, because GCC is not aware of those global variables because it's often its own little pocket folder. So you're gonna have to manually include Win32 and all that stuff. And it's a huge pain in the ass. There's at least I think 3 headers you have to include. I don't know. It's been a while since I actually used C and struggled with it. So I'm just gonna show off some Sokol stuff. It's a single header C library. I didn't want to copi paste fucking Hello World and be oh wow, now you know how to program and go do your own C stuff. No. I think with a Sokol project you could kind of see how to group a bunch of files and link them together to create your C executable, because a lot of stuff, they're just going to show you how to compile one C header or one C file and a header and call it done, and now you don't know how to link O files or create O files. You don't know how to link into different directory paths and all this bullshit. But I'm also not going to go super crazy. I'm just going to show you my batch files, which is basically it's kind of like a make for Windows, and that's really just it's kind of shitty. I'm pretty sure it creates a global variable scope on your computer that doesn't get cleared until you turn off your computer. So it's kind of shitty, but also if you use something like Bash, I think it's doing the same bullshit too. So a lot of these stuff is kind of doing all the same bullshit, so it doesn't really fucking matter. Just preference and some asshole telling you how to write something. Okay, that's all it is. Sokol for the WASM target. It's kind of the same with Clang, but you have to get it in script, and it's kind of like a WASM compiler, I guess. It's set up exactly like Clang, or it tries to be mimicking exactly like Clang, so like a lot of the commands are usually somewhat similar. It's as easy as just going to the Inscription site and downloading it. But to get it working, you have to set up the Inscription environment, which is like you gotta go to the source file where it's downloaded and run the environment batch. Well, on Windows, I don't know where else. Other operating systems, just follow the Inscription guide and it'll tell you what you need to do. But I would recommend you not to set up a global variable for Inscription for like setting this up, because it doesn't close until you like close your command prompt or whatever opened or whatever executed the batch file. So that's kind of shitty, like. But once you got the environment opened for the duration, so once you got the environment open, you got access to the ECC command, which is basically like the Inscription compiler, and you can build the WASM's targets. There's some stuff like for Sokol's shaders, you can have to compile the shaders to GLSL300ES, and to like test it. I just use Python and set up a local host. There's other ways you could probably do it. Python's probably like the most simplest one. And textures. I don't know how textures work in Sokol, because it uses a async fetch, and all the examples for Sokol doesn't use the async fetch besides like the spine example, and even then I'm not too sure. Like it might not actually use it, Don. I don't know. Yeah. I found the documentation kind of confusing to read, because like it gets you to like download this like Dawn build tool system, and when you actually get to like reading all the CMake text, it doesn't really use the Dawn thing that you downloaded. It's just kind of just a bunch of like fucking files just loosely connected, and then when you read through it, it's like one file just kind of does like a switch that switches one directory path to another. So like instead of the native target, it switches over to WASM, and that's all it does. And it's like, well, kind of gassing up the whole thing, huh? But because it's like an async fetch, sometimes it just fails and it just doesn't work. And the workaround for them is just basically baking the texture into your program, which is basically having a byte array that represents the whole picture. Even WASM, like it can mimic the file path operations for opening an image and like reading the bytes, but that too is just pre-allocating a byte array to represent your image. There isn't really like an example where like, hey, from JavaScript we can pipe out a byte array from like the already read image on our browser and just feed the byte array into like an already compiled spot in our WASM target and just fill up that empty spot. Well, of course we're gonna have some hooks on this C++ side just to make it easier just to do all that shit. But there isn't really an example to do so. And I'll be honest, I'm not even that smart to do that, because that's kind of I wouldn't even say it's complicated. It's just it's kind of like those who know, and they won't really tell you, or they don't really realize how simple it would be to explain to people. Just be like, yeah, it's just fucking you just basically set up like a little function pointer, an event, I guess, and on the Java side just async into that function, I guess. Like, I don't know, bro. We're just gluing like JavaScript into like some C++, and that we're calling it a fucking day, bro. So anyways, well, what else can I ramble about? I don't like C++. That's because like a lot of the times it's like encapsulated bullshit where it's nice for classes and stuff, but when you get to reading C++, it's very terrible, because a lot of people don't want global variables or global state, but that's really easy to manage in your head about it. And it's even easier just to like, hey, if it really is shitty, we could break down the whole system, just rebuild it, and be super easy. Well, we're not pot committed into like some inheritance function virtual overloading bullshit. We can just remake everything. And also, classes are kind of just containerized global variables, because sometimes if you're reading like C++ source files, you could be like running down the whole thing, and then there'll be like this one variable that you never encountered in the CPP file, and you're like, what the fuck, what the hell is this? And you search for it. There's only one search that pops up when you search for it, and that's and you're looking at a variable and you don't know what the fuck where it came from. So you don't know where it came from if it's in the header file. So you check the header file, and the header file might have it, or if it does have it, it's this private variable. And now you can't access that private variable because they set up to have a getter that accesses that private variable. Where if you stuck to C and just left that structs, everything's public, so you could always access that variable. You're not jumping through hoops. But that's the nice example. The bullshit example would be more function based, because sometimes those variables aren't really known. They're just there because like all the functions are appended into the class. The classes have the functions, so the methods, but the functions know everything in the containerized global variables, or everything that's in the class, so it can just use it whenever it wants. So now you're always looking at two files to understand like a C++ single file. And sometimes like a variable can just be like a parameter in a function that has a defaulted value. So if you're not aware of that, you could be looking everywhere and be like, well, I don't understand where the fuck this one thing came from. Like, oh, it's fucking a function that got overloaded. It's a function that like passes in a variable, but it doesn't show that it does that because like the defaulted way to write it doesn't it just shows like two parameters. It shows like one parameter instead of like two or three, and now you're like confused. I don't know. It's bullshit. So rambling aside, have fun with C or C++.